Hi students, this is Shekhar sir. Today I will explain about Ohm's law. So Ohm's law is important for class 10th students as well as the class 12th students. So it is the JEE main syllabus, NEET or absent syllabus. Just we have to look at the Ohm's law. What does mean Ohm's law? So Ohm's law means the potential difference between the ends of a conductor is directly proportional to the electric current passing through it at a constant temperature. So, okay, now to understand Ohm's law, here there is a circuit diagram is there. First thing here, I've taken a dry cell capacity is a 1.5 volt. So here I connected to the battery of dry cell to the one end. I connected to the here it is a iron spoke. By using the connecting wires, I connected a battery to the iron spoke. So in the parallel connection, I arranged a voltmeter. This is a voltmeter. I arranged it parallel. Next, by using connecting wires, I arranged here ammeter is there. Here it is a plug key. Ammeter is there. Here it is a plug key. Here is a it is a ammeter. Ammeter used to measure the current. Ammeter used to measure the current. What is the Ohm's law? Why we need to study the Ohm's law? Okay, now without Ohm's law, okay, now we cannot design the bulb. We cannot design the how much fan is rotating, how much fan is speed is there. So in the circuit diagrams, how to design the circuit diagrams, how to construct the different electrical appliance, how much power it is taking, how much voltage is taking, how much current is consuming, how much resistance we need to take, we need to keep. So ఎలక్ట్రికల్ అప్లయన్స్ అన్ని కూడా వర్క్ చేసేది బేస్డ్ ఆన్ ద ఓమ్స్ లా. సో దట్స్ వై వీ నీడ్ టు స్టడీ అబౌట్ ఓమ్స్ లా. సో హియర్ ఓమ్స్ లా మీన్స్, సో టు అండర్స్టాండ్ ఓమ్స్ లా there is a activities there. First thing, here I arranged at here it is as first I taken a battery. Here it is a 1.5 volt. So when we keep the 1.45 volt here, so we have to measure that the current is flowing in this direction. The current is flowing in this direction. We have to measure the voltmeter reading as well as the ammeter reading in the circuit. When we keep the 1.5 volt here, voltmeter reading, it shows the 1.4, approximately 1.4. Next, when we measure the current in ammeter, it shows that 0.28 amperes. 0.28 amperes. Next thing here is here we have to find the V by I ratio. Okay, now we have to find the V by I ratio. When we find the V by I ratio, it is equal to the, here in this case it is equal to the 5 ohms. Next, when we keep the when you continue increasing the voltage, now here I kept the 1.5 volt battery. So it says that 3 volt. Here I applied potential difference 3 volt. I taken 2 dry cells. So it's a potential difference equal to the 3 volt. 1.5 volt plus 1.5 volt. It is equal to the 3 volt. So when I increase the 3 potential difference 3 volt, here 3 volt, the volt in the voltmeter reading, it shows that 2.8, approximately 2.8. The current flow is it is equal to the 0.56 amperes. So the V by A ratio in this case also constant. When I increase, when I take three dry cells, so 3 dry cells capacity, each capacity 1.5. So here it is a 1.5 volt. So current here I am getting is a 4.2 volt. Here it is a 0. Approximately equal to the 74. approximately equal to the 0.84 amperes. The ratios are here also constant. For example, if I will take 4 dry cells, here it is a 6 volt. Okay, now here it will be the 5.6 volt. Here it will be the 1.12 amperes. Next here it is a V by I ratio is the constant. V by I ratio is the constant. So what does mean Ohm's law? Okay, now Ohm's law says that when we increase the potential difference, okay, now battery డ్రై సెల్స్ ఎన్ని ఎక్కువ మనం ఇంక్రీజ్ చేస్తే ఓకేనా కరెంట్ అంత ఎక్కువ ఇంక్రీజ్ అవుతుంది. అంటే పొటెన్షియల్ డిఫరెన్స్ ఇంక్రీజ్ అవుతుంది, కరెంట్ కూడా ఇంక్రీజ్ అవుతుంది. అంటే కరెంట్ ఇంక్రీజ్ అనేది దేని మీద డిపెండ్ అయి ఉందంటే పొటెన్షియల్ డిఫరెన్స్. ఓకేనా, సో V is directly proportional to the I at constant temperature. At constant temperature. Okay, now this is important. At constant temperature. In this case, we have to maintain the iron spoke temperature is the constant. Iron spoke temperature is the constant. So here V is directly proportional to I. ఓకేనా, ఎంత వోల్టేజ్ మనం పెంచుకుంటే పొటెన్షియల్ డిఫరెన్స్ ఎంత ఇంక్రీజ్ చేస్తే కరెంట్ కూడా అంత ఇంక్రీజ్ అవుతుంది. ఓకేనా, ఎంత పొటెన్షియల్ డిఫరెన్స్ ఎంత ఇంక్రీజ్ చేస్తే కరెంట్ కూడా అంతే ఇంక్రీజ్ అవుతుంది. సో V is directly proportional to I. When you remove the proportionality, we can keep the constant V equal to here. Constant is the R. V equal to Ri. Or we can write V equal to IR. Simply it is a Ohm's law. V equal to IR. So here R is called as a resistance. R is called as a resistance. So R is called as a resistance. R equal to V by I. R equal to V by I. Or I equal to V by R. I equal to V by R. It is a Ohm's law. Okay, now in a given circuit, if you want to find the resistance of the how much resistance is there, how much resistance we have to keep to the electrical appliance. For example, bulb కి ఎంత రెసిస్టెన్స్ మెయింటైన్ చేయాలి, టీవీకి ఎంత రెసిస్టెన్స్ మెయింటైన్ చేయాలి, ఎంత కరెంట్ కన్సెప్షన్ తీసుకుంటుంది. సో ఎవ్రీథింగ్ ఇట్ ఈస్ బేస్డ్ ఆన్ ద ఓమ్స్ లా. సింప్లీ ఫస్ట్ కేస్ లో మనం డ్రై సెల్స్ when we take the 1.5 volt dry cell, okay, in the voltmeter reading it shows that 1.4 and the ammeter reading current is a 0.28. So here I taken the conductor is a iron spoke. Here I taken. So when we find the ratio between V by I, so in all cases it is a constant. In all cases it is a constant. When we draw the graph line here between resistance, between voltage and voltage in the y-axis direction, next current in the x-axis direction, current in the x-axis direction, the graph is a straight line which passing from the origin. Okay, now the graph is a straight line which passing from the origin. So this is the graph line. Okay, now we know that tan theta equal to, in this case, tan theta equal to V by R, which is equal, tan theta equal to V by I, which is equal to resistance, which is equal to 5 ohms. Okay, now which is equal to 5 ohms. Okay, now when you draw the graph between voltage and current, graph అనేది ఎలా వస్తుంది? It is a straight line which is passing from the origin. Okay, now which is a straight line which is passing from the origin. Origin నుంచి పాస్ అవుతుంది, origin నుంచి పాస్ అవుతుంది. ఓకేనా, దిస్ ఈస్ ద ఓమ్స్ లా. ఓకేనా, ఓమ్స్ లా it is like a tank. In everyday life it is like a tank. వాటర్ ట్యాంక్ ఎంత హైట్ లో ఉంటే ఓకేనా వాటర్ ఫ్లో కూడా అంత ఫాస్ట్ గా ఉంటుంది. ఇన్ ద సేమ్ వే వెన్ యూ ఇంక్రీజ్ ద పొటెన్షియల్ డిఫరెన్స్, ఓకేనా కంటిన్యూగా మీరు పొటెన్షియల్ డిఫరెన్స్ ఇంక్రీజ్ చేస్తుంటే కరెంట్ కూడా ఇంక్రీజ్ అవుతుంది. ఓకేనా, పొటెన్షియల్ డిఫరెన్స్ ఇంక్రీజ్ అవుతే కరెంట్ కూడా ఇంక్రీజ్ అవుతుంది. ఓకేనా, దిస్ ఈస్ ద V is directly proportional to I. Okay, and when you remove the proportionality, V equal to Ri. V equal to Ri. Here R is called as the resistance. R is called as the resistance. SI unit is a ohm. SI unit is a SI unit of resistance is a ohm. Symbol we have to denote with the okay now ohm. This is the symbol ohm. Okay, now this is the Ohm's law. When you draw the graph between V and I, okay, now V is on the y-axis direction, I is in the x-axis direction. Then here this is the slope. Tan theta equal to slope formula tan theta equal to x2 minus x1 by y2 minus y1. Okay, now in this case, tan theta equal to v2 minus v1 by tan theta equal to v2 minus v1 by I2 minus I1. I2 minus I1. Okay, now tan theta equal to V by I. So it is equal to R. So here it is a graph line here. It is going a straight line which passing from the origin. Origin is a straight line and pass out. So it is about Ohm's law. Okay, now next thing we have to replace iron spoke with LED. We have to replace iron spoke with LED. In the place of iron spoke, when we connect the LED, when we connect here LED, okay, now positive terminal of the LED, longer line of the LED connected to the longer line of the LED connected to the longer line of the LED connected to the positive terminal, smaller line connected to the negative terminal. What will happen? Okay, now when you take the LED between in place of iron spoke, when you take the LED here, when you measure the graph, when you measure the R values, it is not a constant. The graph is not a constant. It is a like a curve. Okay, now it is a like a curve. For example, when you draw the graph between okay, now voltage and current, voltage and current, it is not a straight line. It is not a straight line moving from the origin. It is like a curve. So it says that Ohm's law is not a fundamental law. Ohm's law is not a fundamental law. It is not applicable to the all the materials. It is not applicable to the all the materials. Okay, now in this here I will explain limitations of the Ohm's law. Okay, now once again look at the Ohm's law statement. The potential difference between the ends of a conductor. This is the ends of a conductor is directly proportional to the electric current passing through it at constant temperature. At constant temperature. So potential difference is directly proportional to the current. If you increase the potential difference, the current in the circuit also increases. The current in the circuit also increases. Okay, now once again pause this video. Okay, now note the table and note the statement. Here I will explain the limitations of the Ohm's law. Why Ohm's law is applicable to the some conductors, why Ohm's law is not applicable to the all the materials. So what are the limitations of Ohm's law? Ohm's law is not a fundamental law. Ohm's law is not a fundamental law. So fundamental law means a plus b whole square equal to a square plus b square plus 2ab. So that is a fundamental law. Okay, now here I will explain the limitations of the Ohm's law. Okay, now limitations. Limitations of Ohm's law. Okay, now to maintain the Ohm's law is valid only at constant temperatures. At a constant temperature. Ohm's law is valid. Okay, now first thing here I will write. It is not Ohm's law is not a fundamental law. So it is not a fundamental law. It is not a fundamental law. It is not a fundamental law. What is the fundamental law? For example, here a plus b whole square. A plus b whole square equal to a square plus 2ab plus b square. So this is a fundamental law. When you keep any numbers here, it is a valid. When you take, for example, a equal to, when you take 2, b equal to 2, it is valid. B equal to 3, it is valid. If you take 1, a equal to 1, b equal to 2, LHS equal to RHS, it is valid. It is a fundamental law. Okay, all algebraic laws is a fundamental law. Next Newton's law. Okay na, Newton's law. Next Newton's laws. Next Coulomb's laws. Okay na, Coulomb's laws, Newton's laws is a fundamental laws. Okay na, but Ohm's law is not a fundamental law because it is a temperature dependent. It is a temperature dependent. It is a temperature dependent. The temperature is increasing. Okay na. Even the metals also does not obey the Ohm's law. Metals also does not obey the Ohm's law at high temperature. Okay na. If temperature increases, then resistance also increases. Resistance also increases. Okay, now if the temperature increases, resistance also increases. So there is a change in the constant. V by E is not equal to constant. When the temperature is changing, resistance is changing. Then V by E ratio is not equal to constant. Even though metals also does not obey the Ohm's law at high temperatures. Metals also does not obey the Ohm's law at high temperature. Next thing is it depends on the nature of the material. It depends on the nature of materials. Nature of materials. Approximately all the metals, some metals obey the Ohm's law. Some metals obey the Ohm's law like copper, aluminium. Obey the Ohm's law at a constant temperature. At a constant temperature. But some gases conductors. Some gases conductors. Next semiconductors like germanium. Semiconductors like germanium, silicon. Next diodes, transistors. Okay, now these are does not obey the Ohm's law. Okay, now Ohm's law అనేది all the materials is not follow the Ohm's law. Some metals only obeys the Ohm's law at a constant temperature. Here condition is a constant temperature. At constant temperature, some metals obeys the Ohm's law. Okay, now. But some other materials does not obey the Ohm's law, like a gaseous conductor. Next semiconductors like germanium, silicon, diodes, transistors. So these are not obey the Ohm's law because when you draw the graph here, it is not a curve line. It is not a straight line. It is like a curve. Moving from the here. స్టార్టింగ్ ఫ్రమ్ ద ఆరిజిన్ కరువు లాగా వస్తుంది అనమాట గ్రాఫ్. సో కరువు లాగా వస్తుంది కాబట్టి ఓకేనా, ఓమ్స్ లా ఇస్ నాట్ ఎ ఫండమెంటల్ లా. సో దీస్ ఆర్ ద లిమిటేషన్స్ ఆఫ్ ద ఓమ్స్ లా. ఓకేనా. సో వాట్ ఈస్ ద యూజ్ ఆఫ్ ఓమ్స్ లా అంటే ఫ్యాన్ ఎంత స్పీడ్ తిరగాలి, సర్క్యూట్ హౌ వీ కెన్ కన్స్ట్రక్ట్ ద సర్క్యూట్. నెక్స్ట్ హౌ టు మెయింటైన్ ద రెసిస్టెన్స్ టు ద డిఫరెంట్ బల్బ్స్. ఓకేనా. హౌ టు క్యాల్కులేట్ ద పవర్. Power formula we know that I square R. Okay, now by using the Ohm's law, we can calculate the how much power consumed in our home per month. Okay, now that is the use of a Ohm's law. Okay, now once again you can pause this video. Okay, now watch my video, watch my teaching, comment your opinion in the comment box. Please like my video, subscribe it and share to your friends. Thank you.